In this video, we are going to discuss about the principle of duality in electric network. This is the last topic from the fourth unit. Okay, if two or more electrical networks possess the similar types of equation, then we can say that it is the dual networks. The duality is said to exist between them if mesh equation of one of the network has same form as the nodal equation of others. Now let's consider about the RLC series network. Here we have the voltage source which is connected in series with the RL and C network. Now for R, VR is given by IR, and then for the inductor is given by L di by dt, and then for the capacitor is given by VC is equal to 1 by C of integral I dt. Now if we apply the Kirchoff's voltage law in this network, you will have the total V, supply voltage V, is equal to the voltage at the resistor plus voltage at inductor plus voltage at the capacitor. And if you replace this one, V will be equal to IR plus L di by dt plus 1 by C integral I dt. Now let's make this one as the equation 1. And then similarly, if you consider about the parallel R, L and C network. Okay, similarly, if you consider about the parallel R, L and C network, you can write the network like this. We have current source which is connected in parallel with the R. The reciprocal of R is conductance G. And then in place of inductor, we are writing it with the capacitor C, and then for the capacitor we are replacing it with the inductor L. And then if we apply the Kirchoff's the current law in the second network, your total current I will be equal to Ig plus Ic plus IL. And then if we replace it with this the values, then we'll have Ig will be equal to Gv plus, then you have Ic C of dV by dt plus 1 by L of integral V dt. Now let's name this one as the second equation. And then if you compare with equation 1 and 2, if you compare equation, okay, comparing equation 1 and equation 2, we can say that in place of the voltage source V, we are replacing it with the current source I. And then in place of the R, we are replacing it with the conductance G. And then in place of the inductor L, we are replacing it with the capacitor. And then in place of the capacitor, we are replacing it with the inductor. So comparing the equation 1 and equation 2, the mesh equation, this mesh equation, okay, this mesh equation of RLC series circuit, and then the nodal equation of this RLC parallel circuit are in the similar form. See, we have this form here. This is one of the form for the mesh equation, and then again we have one form here. Now this is from the nodal equation. If you compare these two, they are similar in nature. So in that case, we can call as there is a duality between these two network. So for that one, we are simply replacing with the voltage with the current source, then the resistor with the conductor, the conductance G, and the inductor with the capacitor, and then capacitor with the inductor. And then we also have the other representations of the quantities in the original network and the dual network. For example, okay, for the electrical quantities, we can transform from one network to another network like this. The current source, we can replace it with the voltage source, then KVL with the Kirchoff's current law, then mesh with the node, and then short circuit with the open circuit, then series circuit with the parallel circuit, or these are the interchangeable, right? See, I have written the arrow in both the directions. So if it is voltage source, we can replace it with the current source. If it is current source, we can replace it with the voltage source, because we have seen that there is the duality in the network. Then series circuit with the parallel circuit, inductor with the capacitor, and the capacitor with the inductor, R with the conductors G, or the G with the resistor R. And we can also replace open switch with the closed switch, or closed switch with the open switch. Now these are the some of the representation of the quantities in original network and the dual network. So let's now try to solve an example using the principle of duality, or in other words, we are going to convert from one network to another network using the principle of duality. Okay, now this is the example that we are going to solve. Example here, draw the dual network for the RLC series circuit. Now in our previous explanation, we have discussed that how we have reached into this one, because we are simply replacing it with the R with the G, L with the C, and then the C with the L. Now this one is in this explanation, I have not touched on how we got like this, how we got that R is replaced with the G, which is in parallel with the current source. I have not shown about how we have reached to this network. Now in our example, I'm going to explain how we are going to develop this one into RLC parallel circuit. Now the first step is we have to identify the number of loop. Now in this case, we have only one loop. Now in each loop, one dot is placed. So see, in this loop, there's only one loop here, so we can place one dot inside the loop. Okay, let's see, this has dot number A, and then each dot inside each loop. Okay, and now this dot represents the node. Now when you are transferring or changing this one to the parallel network, this dot will represent the node. Now one of the dot is placed outside the loop. Now this dot is also called as a reference dot. Okay, we are replacing we are naming it as a reference node. Okay, now step 1, we have identified the number of loop. Okay, in this case we have only one loop. And then in the second step, okay, I'm writing here step 2, place a dot in each loop. And then third step, step 3, one dot is placed outside the loop. Now this step number 3 is the reference node. And then in the fourth step, okay, in the fourth step, step 4, in the fourth step, we have to connect the dot. Connect the dot. Okay, connect the dot by line. Okay, connect the dot by the line. Now this line should cut one branch only. Okay, in the step 4, we have to connect the dot by line. Okay, I think when you write the solid line, you will get confused. Instead of line, you can write dotted line. Dotted line. This dotted line should cut one branch only. Now, okay, we are done with the step number 1. We have identified the number of loop, and then step number 2, place a dot in each loop. Okay, we have placed a dot and name it as A, and one dot is placed outside the loop. Okay, we have placed one dot outside the loop, and then fourth step, we have to connect the dot by dotted line. So, and then it says there's a condition, this dotted line should cut one branch only, which means, okay, now let's connect this dot A and reference node. Now we are drawing the dotted line, and then that dotted line is cutting the one branch only, okay, one branch only at a time. And then again, let's also connect this dot A and A through R, and then again we have node A and reference node through this L, and then again we have this from A and reference node connecting through this C. Okay, this is not the one. Now from this, now we have to transfer it to the parallel circuit. Now we know that in the dual network, this V can be replaced with the current source I, R can be replaced with G, L can be replaced with the C, and then C can be replaced with the L, and then this series network can be replaced with the parallel network. Now especially when it comes to the voltage source, converting it to the current source, we have to know about the current direction. See, now to give the current direction, it should be always pointing towards the positive side. Here we have plus here, negative is here, so our current direction should be in the positive direction. Now in place of the voltage, okay, let's pass. Now in order to transform this one, let's write the node A here, and then we have a reference node here. Okay, I hope it's visible. And then from the node A and that reference node, it is connected with the voltage source, but when you convert it to the when you use the principle of the duality, it can be replaced it with the current source pointing towards positive side, and then it is connected with the point A and reference node. And then again we have R, that A and reference node is connected through the resistor R. So this one again we can replace it with the conductance G here. Okay, let's write simply like this, and then this is G. Again point A is connected to the reference node with the conductance G, and then okay, let's write point A here, and then A and reference node is connected with the inductor. So in while we are converting that one, so we have to replace it with the capacitor. And then okay, this one is I, G, then C, and then similarly you can replace that C with the inductor L. Now this is the principle of duality, how we are transforming it from the that series RLC circuit to the parallel RLC network, or simply we are transforming this mesh. Now this is one mesh, right, into the node here. Now this is called the nodal network here. So that's it about the principle of duality. And then let's also solve the example. Okay, now this is the second example that we're going to solve. Draw the dual network for the given network. Now this is the given network. Now okay, I'm going to directly solve in the question network itself here. Our first step is we have to identify the loops, right? In this case we have two loops. Let's say loop number 1 and loop number 2. Now in each loop we have to place a dot. Okay, let's say this one is dot number A, dot number B, and then the third step is we have to place another dot outside the loop. Okay, so let's write this one as a reference dot. And then in the fourth step we have to connect the node A and the reference node, and node B and the reference node, or sometime we may also have to connect node A and the node B. Now while connecting the nodes, remember that we have to, that dotted line have to cross through only one branch at a time. So from node A and reference node we can cut through the current source here, and then another node A we can connect to reference node through the inductor L. And then now if you are trying to cut node A and the R1, it will be like this. So you may have to cross this either L and then cut R, and then again you will come through this branch. So this is violating our rule, because it says that while connecting the node it should cut only one branch at a time. So this, now the maximum number of branch that the node A can cut is only 2 in this case. And then for the node B, again we can connect it with we can first cut with the R1, and then we can connect it here, and then again you can cut it through the R2 and then connect it to the reference node. And then for the branch C, this the capacitor here, you can simply cut by the node A and B. Now that's it about the fourth step. And then in the fifth step we can transfer it into the network. Now we have two nodes here and then one reference node, node A, node B, and then we have the reference node. Now node A and node B is connected with the capacitor here. Now when you are transferring, we can simply write with the inductor L. And then we have node A and a reference node connected through the current source. For this one we can simply replace it the voltage source. Now how to write about the polarity? Current direction is pointing towards up, so plus will be here and negative will be here, so we are replacing it with the voltage V. And then again A and R are connected, so we can replace it with the capacitor C, because here it is inductor, so it's C here. And then B here, B and reference node are connected with the R1, so in place of R1 you can write it with the G1, and then again with the G1 and then G2. So that's it about the network transformation. Now this is the final network that we got it from this original network. And then other option could be also, you can simplify this R1 and R2 in the beginning itself, then you will have only one branch, so you can cut that one branch and then you can replace it with the G here. It's the same thing, like if you are having the two branch here, you have to write here two branch here, or if you are simplifying this one, you will have only one branch in this. So it's the same the similar thing. I hope you have understood it well. If you have any doubt, let's discuss, or you can just drop message in the WhatsApp group that we have, or you can either send me email. That's it about the unit 4. And then in the next video we are going to discuss about the fifth unit. It's all about the AC circuit.